In this video, we are going to see how to convert decimal fractions to binary. The fractional part of a number is found by successively multiplying the given fractional part of the decimal number repeatedly by 2 and noting the carriers in a forward order. This is done until the value becomes 0, thus producing the binary equivalent. So in this case, if the multiplication process produces a product greater than 1, the carry is a 1. And if the multiplication process produces a product less than 1, the carry is 0. We'll follow the following 5 steps as we perform this conversion from decimal fractions to binary. Step number 1. Take decimal number as a multiplicand. Multiply this fraction decimal by number 2. The integral part of the resultant decimal number will be the first digit of fractional binary number, and then you can start by repeating step number 1 using only fractional parts of the decimal number, and then step number 2. Repeat the above 2 steps until the number becomes 0. We'll look at examples so that we see how to work around this conversion of decimals fraction. Example number 1. Convert decimal fraction number 0.1825 to binary. So to convert this fractional number to binary, we'll follow the 5 steps that we just mentioned. And the first thing is we pick this number as a multiplicand and we multiplied by 2. So I'll pick this number 0.8125, then I multiplied by 2. And this gives me 1.625. So I'll write the integer part of the resultant here and the decimal part as a remainder, which is 0.625. The coefficient is equivalent to the integer. Therefore, the coefficient a minus 1 is equivalent to 1. So then I'll carry this remainder again here. Then I perform the same multiplication. So this is 0.625 multiplied by 2, which gives me 1.25. I write the integer here 1, then the other side is 0.25. Therefore, the coefficient a minus 2 is equivalent to 1. Again, carry the same coefficient to this other side, I mean the remainder. So I have 0.25 multiplied by 2, which gives me 0.5. So the integer in this case is 0, and then on this side it is 50. So the coefficient a minus 3 is equivalent to 0. Okay. Similarly, I'll pick this remainder, which is 0.5, then I multiply by 2, which gives me the value 1, and the remainder is 0. So the coefficient here, a minus 4, is equivalent to 1. And finally, the remainder here was 0. I can just bring that 0 here, multiply by 2, which basically we get 0, and we can write a minus 5 equals to 0. So the answer in terms of a binary will be given as 0.8125, that was to base 10. When you convert to binary, will be a minus 1, a minus 2, remember there's a dot here, a minus 3, a minus 4, a minus 5, and to base 2. So this will be given as 0.11010 and to base 2. Alternatively, we can write the answer in a top-down order in this manner. Therefore, we can easily say that the number 0.8125 can be given as starting from a minus 1 in that order is going to be 0.11010 to base 2. Example number 2. Convert the decimal fraction number 0.7 to binary. And we'll follow the same steps we did in the previous example. So I'll pick that number 0.7 multiplied by 2, which gives me 1.4. So I write 1 as an integer, and on the remainder we write 0.4. And the coefficient a minus 1 will be equivalent to 1. It is equivalent to the integers. Then I pick this remainder, that is the fraction part of the result. Then I further multiply by 2, so I bring this 0.4 here. Then I have 0.4 multiplied by 2, which gives me 0.8. So the integer is 0, and then the remainder will be 0.8, and a minus 2 will be equivalent to 0. I repeat the same procedure. So this 0.8 multiplied by 2, which I get 1.6. So the integer is 1, and the remainder is 0.6, and 8 minus 3 is equivalent to 1. 0.6 multiplied by 2 will be equivalent to 1.2. So the integer is 1, and the remainder is 0.2, and 8 minus 4 in that case is equivalent to 1. I repeat the same procedure. 0.2 multiplied by 2, which gives me 0.4. So I write the 0 as an integer and 0.4 as a remainder, and 8 minus 5 in this case is 0. 0.4 multiplied by 2, I get 0.8. So that is 0 is 0.8. I have 8 minus 6 as 0. The same procedure. 0.8 multiplied by 2 will be equivalent to 1.6. So I write 1, remainder 0.6, and I have 8 minus 7 as 1. The same procedure. 0.6 multiplied by 2, I get 1.2. So I write here 1, and then I have 0.2, and 8 minus 8 therefore is equivalent to 1. So notice one thing, that the process will keep on repeating itself, and it will repeat itself indefinitely the exact way. That is, after every 4 steps. That is, for example, from here all the way to here. Then we repeat another 4 steps. So here we expect to have a 0. Then another 4 steps, 0, 1, 1, 0, 8. And it will repeat the same way indefinitely. Therefore, the answer in this case is given as 0.710 will be equivalent to a negative 1, a negative 2, a negative 3, a negative 4, a negative 5, etc. This can be written as 0.10110, then 0110, 0110, etc. An overbar can be used to denote indefinitely repeated bits. So in this case, we can write it in this manner. So we can write it as 0.10110, and we indicate those repeating bits using an overbar. And this is the answer in binary. So for practice exercises, convert the following decimal fractions to binary. Number 1, 0.625, number 2, 0.883, and number 3, 0.33. And provide the solutions or the answers on the comment section.